Hey everybody, it's Mr. Roy. Haley was kind enough to let me know about a little issue that some of you might be facing, and so I wanted to address that. It has to do with making graphs using Microsoft Excel and then using it to try and find trend lines. And of course putting on the equation of our line and our R-squared value to figure out which kind of function is going to best represent our data. So here's the thing. If you are using Excel and you go to use the online version through your browser, it's not going to work. The online version isn't able to do trend lines. So here's my first recommendation for dealing with that. My first recommendation is that you go to office.com, or if you just Google Office 365, it's going to take you here. And there's a little button up here that says Install Office. And if you click on that, you can install all the Office 365 apps. Because you're part of Lakehead Public Schools, you have access to all of them. So that'll update, it'll give you the most recent version of Word and PowerPoint and Excel. If you already have some of those installed, it'll give you the most updated version of all of those apps. And you can see them all here on the left side of your screen. Okay, so that's what I recommend first, is just install Office, go to office.com, log in using your Lakehead login, install Office, and you've got the most up-to-date version of Excel, and that'll work great. Here's another option if that's something that for whatever reason you don't want to do that. You can instead use Google Sheets, which is the Google version of Excel. So it's spreadsheeting software through Google. To do that, you're going to need either a YouTube account or a Gmail account, some type of Google account. If you've got either of those, you've got a Google account. And what you're going to do when you're logged into your Google account, you'll see, as you can see in the upper right corner of my screen, here's my Google Apps. I'm going to click on those and I'm going to go to Google Sheets. So I'll choose Google Sheets. It's going to open up my Google Sheets, and I've got a few of them already. I love spreadsheets. I use spreadsheets for everything. In this case, I've got one that I already made up, but you would want to click blank. You'd be starting with a blank spreadsheet. You'd click that, and it would open up a blank spreadsheet that would look just like the one in Excel. I'm going to open this one that I've already started working on here. So in this spreadsheet, I just took some data. I made myself a nice cup of tea, and I used a thermometer. I poured the hot water into my teacup, and I just let it sit, and every minute that went by I recorded the temperature on that thermometer and I wrote it down, and I just typed it into this spreadsheet here. I've got my time in minutes and I've got my temperature in degrees Celsius. Now, did I actually do this experiment? Maybe I didn't. Maybe I just made these numbers up, but this is for demonstration purposes anyway, so that'll work just fine. So here's what I'm going to do now that I'm using this type of spreadsheet through Microsoft Sheets. Again, this is free if you've got a Google account, which is free to get. So I'm going to grab my data exactly as the same as I do with Microsoft Excel. This time I'm going to go up to Insert up here at the top. And I'm going to click Insert. So I'm going to say, okay, I would like to insert a chart. So I'm going to head down here until I find chart, and I'll say, yes, please insert a chart. There it is. There's my chart. Now, when your chart shows up, chances are it's not going to be in this XY scatter form. It's probably going to look like this. Okay, but that's not how we want it. So we've got to go into our chart editor here, and under Setup, I'm going to choose, instead of a line chart, I want a scatter plot. So here's my scatter plot. Okay. Now it's fortunately figured all this out already in terms of like what to call, what to title my graph. It has an idea about what it wants to title it, and it's put my axes on already, which is really nice. It's figured that out for me, so I didn't have to do any of that, which is nice and convenient. Here's a few things I'm going to have to do to get my trend line in there, though. Okay, so first thing I'm going to do is I'm going to, that was in Setup, I'm going to go over to Customize. So here in my chart editor, I'm going into Customize. Okay, and of course I can change my chart title and axes, but those look okay to me. And I'm going to scroll down under Customize, and I'm going to click on Series. Okay, and under Series, I've got some choices here. You'll notice that I have a nice thing here where I can click Trend Line. So I'm going to click Trend Line, and it's going to put a trend line on for me. Of course, the thing it's going to assume first is that I want a linear one. And maybe I do. I'm not sure. That, to me, doesn't look like it's a great fit for my data, but maybe that's the one that I want. So what I want to do is, a little further down, I'm going to ask to include the R-squared value. And there I can see my R-squared value. Okay, so it's showing me blue dots, and there's my trend line. It's calling it series 1. We'll rename that later. But right now it says r squared equals 0.907. And that's okay, I guess. But I think I would like one that is, maybe I'll make that a little bigger. Let's see if I can make it a little easier to see. There we go. Maybe we'll bring it all the way up to 18 so you can see it better. So r squared value of 0.907. Let's see if I can do better. So I'm going to go back to series, and instead of linear, I'm going to change that. So I'm going to click linear, and now I'm going to try an exponential one. And my r squared value now is 0.969, so that's better. So an exponential function is a better representation. So 0.969, let's see if we can do better. Let's try a polynomial, and you'll see it's a polynomial to degree 2. That's probably as far as we want to go. You could take a polynomial and put it up to like 6th degree, and it'll make some crazy function that would fit your data well, but chances are a polynomial degree 2, which is a quadratic, right? It's got an x squared, is going to be what we want. Now look at this, an r squared value of 0.998. Whew, that's almost perfect. This data is almost perfectly quadratic. Now, if I hadn't just made this data up, and if this was real data, I would feel pretty comfortable at that point saying the cooling curve on liquids appears to have a quadratic form. In reality, I don't know. You'd have to figure that out. If someone wants to do that, that would be a really cool experiment if you have a thermometer at home. I don't have a thermometer at home, and I didn't actually take this data, so it'd be interesting to find out. If you want to do that, hey, that'd be a cool experiment. Let's try logarithmic, though, see if we can beat it. 0.995 versus 0.998, so it's close, but no, it doesn't beat it. How about power series? 0.974, no. We're not going to do moving average. So it looks like a polynomial, so this is a quadratic, right? This is a quadratic with an x squared as our highest degree. Looks like that's our winner. So that's going to be our r squared value. Now, I do want my equation of this quadratic on there as well. So how do I get my equation on there? It says here under label, I've got custom right now. I want to change that. I'm going to change it to use equation. Boom, there's my equation. Now this thing does something that's a little funny with the equation. For some reason, it writes it in the reverse order we normally write it. So the x squared term, 0.784 times x squared, they wrote at the end, and they wrote that like just number coefficient first. But I mean, that's fine. That doesn't really matter. So it's 111 plus negative 14.9, so the same as 111 minus 14.9x plus 0.784x squared. So that's a quadratic. If we were to write that, I'd write y equals 0.784x squared minus 14.9x plus 111. That's my equation. And if I wanted to see how the cooling trend changed further, I would plug in another number for x. Instead of 10 minutes, maybe I'd try 40 minutes. And so I'd put in a 40 wherever I see an x in my equation, plug it in and see what I get. Now if I want to copy this chart and I want to put this chart into a Word document, there's three little bullet points up here, so I can click those. And I got a couple of options. I could copy the chart, although that seems to be a pain for me. It doesn't seem to be working very well. So what I would recommend is that you actually download the chart as a PNG image. So that's just an image format. You could do it as a PDF as well, but I think just as an image is going to make it really easy to copy and paste into a Word document. So maybe I'll do that. I'll download it as an image. And that should download it like that, and then so I want to see it in my folder. I'm going to have a look. Here it is. I'm going to copy that, and I'll open a new Word document. Here we go. And now I can just paste that right in there. Boom, there's our graph into a nice Word document. Awesome. And I might want to clean it up a bit and change a few things around. You can play around with it, but that's basically how you can get your graph into your Word document. And then I can resize it to whatever size I want, and I can use this to complete my report. Okay? So I hope that helps, and that is another option. If you would rather not install Excel, or you don't have a means for installing Excel, this is a nice easy way to create the exact same type of graph where you can get the equation of the line or curve, and you can figure out your r-squared value to find whichever type of function is the best one for you. So I hope this helps, and now you've got a brand new option. Thanks again, Haley, for pointing out that we might have a little problem there.